this question, which is x to 2/5. So you want x to 2/5, let's say, equals 3 this time. So in order to eliminate the denominator of that fraction, first we will have to raise everything to the 5th power. So the left-hand side is really x squared. And this one, 3 to the 5th, is 3, so it's 9 times 9, so it's 81 times 3, 243. Okay, so now this is much easier. We know this, so we take the square root, but remember now, in this case, I have to put plus or minus. Why do I have to put plus or minus? Because this is quadratic. X squared equals 243 is quadratic, and when I take the square root, I get plus or minus. Actually, not from this side, as you remember. The correct step is this. And we learned this last time. From here, we have positive the square root of 243 and negative the square root of 243. So the plus or minus do not come from the square root. They come from the left-hand side. Other questions for me? Is there anything else that you... Yes, please.
I don't remember the exact story, but it was like one of those word problems. You got to fill in an equation.
Yeah.
But I did what you told us to do, like, x equals this, whatever the letters meant. But you want me to just give you the
Yes,
model?
that will be the best, because then everyone knows what we're talking about.
So the model is E equals 0.2.
Uppercase E, lowercase e.
Uppercase E.
Okay. And what is the variable in the problem?
It was
What is the variable that you are going to give me? Which?
E equals 0.2 x.
Okay, so it's E of x. That's all I meant. So 0.2x.
And then it's 3 over 2. That's
the power, 3 over 2.
Yeah, and that's the model.
Okay, this is the model. So this is just a word problem. Can you tell us the number or section or?
So it says x is going to be the distance from the center, so it's the solar system.
Okay.
The planet.
Okay.
And E equals the number of days of the planet. And then it says we're going to find planet B, and it says it's 224.2 days.
So E equals 240.
No, 224.2.
224.2 days.
Mm-hmm.
And they're asking us to find the distance.
Yes.
Okay, perfect. Very good question. Can you tell us which section this is coming from?
1.6.
So it's coming from 1.6, and the problem for everyone to know when they encounter this? 20?
Mm-hmm.
Very good. Okay, so we're given a model. We are given E, which is the number of days to get from one planet to another. And the model is supposed to give us the distance between the. I forgot to ask you. Was this okay? Is this what you meant?
Yeah.
Okay.
Yes.
Okay. Perfect.
Thank you.
Sure. Okay. So now we're asked to determine the distance between the two planets. Is that my understanding? Is that correct?
From the center to the planet B.
Okay.
Which is the 224.
So, but that's what the model is giving us, right? Okay. Good. So all we have to do is, can anyone give us an idea? Say it again. I have to write something. I cannot divide anything yet. I don't have anything to divide. I have to write something that I will eventually divide, but I haven't written anything yet. 224.2, excellent, equals. Very good, to 3/2. Awesome. This is always the first step. Remember those two key words. What are the two key words? Every time you look at or think in terms of math, the two key words, they are? Excellent. Please remember. So in this case, I have to simplify. And yes, I will divide both sides by 0.2. Now I'm going to write it in the order I like. So I'm going to write x to 3/2. And this is 2242 divided by, so 2242 divided by 2, actually. So this is 1121. I multiply the top and the bottom by 10, so I don't have to worry about decimal numbers. Okay, now let's think. What type of equation is this? And the answer is, it's an equation you can say two different things. What are the two different things that you can classify, or two categories that you can classify this equation in? Excellent. Radical, or what is the second one? Excellent. Radical, of course, because it's a fractional exponent. So what is the second one? An equation with a
Fractional exponent.
excellent. Very good. Good. So I would like to eliminate the denominator first. What do I do to both sides to eliminate the denominator? Excellent. Square both sides. So then I get x to the third equals 1, 1, 2, 1 squared, whatever that number is. I don't care for it. What do I do now to get x by itself?
Cube root.
Yes, of course. The cube root. So then I have x equals the cube root of 1, 1, 2, 1 squared. So here's how we do this. Yes, any questions? Kayla, you had a question?
No, never mind.
You answered your own? You can teach today.
Maybe, go ahead. No, I'm good.
Okay. I'm checking 1 second here, a video from last week because I need to delete it so I can record yours. It works, okay. For some reason it didn't get deleted. So this one, 2, 6. Okay, it's done. So we have, you know me already. I will put 1, 1, 2, 1 power, and of course in parentheses 2 over 3. You don't have to, right? You can go to math and put the cube root of 1, 1, 2, 1 squared. So in this case, I have this. Now, they're probably giving us some information about how to present the answer. How do they want the answer? Do they want rounded
Oh,
up?
rounded to the whole number. I remember that.
Or rounded to the whole number?
Yeah.
So in this case, it's 108.
Yeah.
So the answer is 108, if that's what they want.
How did you enter that in the text editing?
That's let me show you two different ways. This is what lazy people do. They just put a caret in 2/3. But if you want to be fancy, you will go through this. But you have to put the index first. You will not take it otherwise. So you have to put the index. In our case, the index is 3. Then you click on 5. And then you put 1, 1, 2, 1. You know me, I have to have parentheses. I don't trust anything without parentheses. And then you'll get the same answer. But for me, this is too long. I don't want to do this and look for this and look for math and plug in first the index and then come back and put the square, the cube root. I don't care for all this. So what I do is I write 1, 1, 2, 1. I put the power, the symbol for the power, and in parentheses, this must be in parentheses, 2 over 3, because that's
so
what.
You put 2 over 3. Why? Because I just see 3 over 2 on the.
But
I wrote it on.
But wait. So the cube root of 1, 1, 2, 1 is 1, 1, 2, 1 of the power over the index.
Okay. I just,
So that's the correct form, right? From here, so this is x equals 1, 1, 2, 1 raised to 2 over 3. 3 is, the denominator is always the index. The power is the power. Okay, good. Very, very good questions. Thank you.
that's all my questions.
Okay, that's fine. You enlightened us today. Thank you. And I'm expecting everyone to do that. Okay, great job. Perfect. So we're back to absolute value inequalities unless you need anything else. Anyone? Anyone? Anyone once? Twice? So I am back. Let me show you one thing when we're done with this, and it's almost done with linear and absolute value inequalities. So this chapter is almost done. I would like you to look here to see the review exercises in your book. Review for each section. You only need the sections that we covered, but all these problems have the answer in the back. Then there is a chapter 1 test. Only do the problems that we covered in class. Don't choose anything else, right? And check the answer in the back. And then you can say, I am ready for chapter 2. Okay, back to, I know I talked too much. I'm sorry, my apologies. Okay, so let's look at 74. on page 203, and that is the absolute value of 5x minus 2 greater than 13. We know that we only have two types of absolute value inequalities. Can anyone identify which type this one is? This one? Is it the one in the chain, or is it the one with completely separate two inequalities, completely separate from each other, and the union will be in the final answer?
It's gonna be a union.
Yes. So there is nothing you can do. I'm just making a point. Do not erase anything. You cannot solve this problem unless you know how to convert it into something simple that we can work with. So how do I convert that into something simple? I'm ready.
Is it negative 13? Did you put the negative on the other side?
What other side? You haven't told me. You left. You haven't told me right. What do you mean by other side? I know that you're on the right track, but I don't know what to write first.
5x minus 2. Minus 13. That's what minus 13.
Let's go back to the notes from last time. If you figure it out, please tell me. Don't torture us. And I'll put it in.
Oh. 5x minus 2 minus 13 and plus 13 on the right side and the left side.
That's not that type. I cannot stress enough. The first step before you do anything is redoing the problems we did in class. That's the very first step. Okay, so then, which type is it? So please tell me what to write.
5x minus 2.
Greater than. Good. Greater than.
13.
Yes. Or. Yes. 5x minus 2. Excellent. Great job. Great job. That's exactly what I need. Because it says 13, not even 13, and more. To the left-hand side of negative 13, to the right-hand side of 13.
But can you write that in one sentence, right? Combine that?
Never.
No?
Never. Let's go back to the notes. Never. 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 This is never. Do not touch it. Do not try it. I cannot give any credit if you do. This is the only one that goes in a chain. Do not try anything here. We cannot reinvent the wheel. This was invented thousands and thousands of years ago. Don't try. So please, 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 do not try.
So what's the difference? What?
In between, outside. Huge difference. In between, outside. Two different concepts. One concept is in between. The other concept is outside. You cannot find a number that is less than negative 13 and at the same time greater than 13.
Okay.
Do not combine those two inequalities. I know it may be confusing. Do not attempt that, please. Good. So the first one I add 2. So I have 5x greater than 15 or x greater than 3. Very good question, actually. Because if we don't talk about these things, then you may draw conclusions that, are not good. So then 5x less than negative 11, because we're adding 2. So x less than negative 11 divided by 5. These two inequalities have nothing in common. As you notice, this is more than 3 and this is less than a negative number. Therefore, the solution must have the symbol of union in between. I hope I convinced you of that. Okay, so now please tell me what to write. I'll see it on the first test, but I don't want to see the mistake. Okay, so can anyone give us the solution?
It's gonna be parentheses, 3, comma, infinity. And then the other one's gonna be negative infinity. And then negative 11.
That's it. Very good. Please let me know if we need more examples. Yes? Would you like to choose? Or I will. Thank you for your vote of confidence. If you allow me to. I'm trying to open this so I have it ready. Okay, so here's another example. Let's say problem 80. 5. The absolute value of 2x plus 1 minus 3 greater than or equal to 9. Okay, what is the first step when we look at this inequality? What do we conclude?
Gonna add 3.
Of course, we have to clean it up. We have to add 3, so this is 5. The absolute value 2x plus 1 greater than or equal to 12. Excellent. Next step. Very good. It's completely cleaned up right now. At this point, we have to think. So what do we do?
It's gonna be a union.
Oh, we're so far from it. But yes, absolutely. Eventually, yes. It will be the union. So can anyone give us the two options?
Two x plus 1. Greater than or equal to 12 over 5.
Excellent.
2x plus 1
Excellent.
less than or equal to 12 over 5. Yeah, negative.
You understand that if we write less than or equal to, you will include the in between and you cannot. Is that clear? Perfect. Good. So I'm going to subtract 1 and then divide by 2. You can say, no, I would like to eliminate fractions first, and I'll do that. If we want to eliminate fractions, we will multiply both sides, all terms, by, yes, that's the only denominator. So then I have 10x plus 5 greater or equal to 12, and this is easier to manipulate or take care of. We're not changing anything. So I'm subtracting 5, and I get 7. 10x greater or equal to 7, and x greater or equal to 7 divided by 10. And this is done. It's the first one, and it's done. Now I have to look at the second one. For simplicity, I'm going to do the same thing. I'm going to multiply both sides by 5 to eliminate fractions.
Good question.
Please do. Yes?
Multiply by 5 because of the denominator.
Yes, that was the least common denominator. Yes. And 5 will eliminate everything in this case. But now if I have here 1 over 6, the least common denominator will be 30 or something else, right? If I don't have, so it depends. Right now we only had one denominator, so we only multiplied by 5. Okay, so the other one is 10x plus 5 less than or equal to negative 12. I move 5 as we know, 10x less than or equal to negative 17. So x less than or equal to negative 17 divided by 10. So at this point, I'm ready to write the union. Can anyone give us the final answer for this? And please remember, no, do not combine them. You cannot do that. Imagine like this, one of them is in Maryland and the other one in California. You cannot combine them. It has to be the union. Say it again. We never use brackets for infinities because they are not numbers. Very good point. So please remember, infinities are not numbers. For you, infinity may be a billion. For me, it is 1 billion. So and for somebody else, it can be 15 billion. So we don't know what that is. It's just a symbol. Yes. So negative infinity, comma. Very good. With a bracket because of the equal symbol. Excellent. And now a bracket again. 7 over 10, comma infinity. This is the solution. Any questions, please? Okay, we're going to look at some word problems here. On page 205, before we start chapter 2. On page 205, let's look at 128. An elevator at a construction site has a maximum capacity of 2,800 pounds. Max 2,800 pounds. I don't know what the problem is all about, but when I hear max 2,800 pounds, I do this in my head. So in other words, the elevator cannot, whatever we put in it, people or otherwise, it cannot exceed the weight of 2,800 pounds. It will not move. It's built for 2,800 pounds max. Okay, next. If the elevator operator weighs 245 pounds, so operator 245, and each cement bag 95 each. How many bags of cement can be safely lifted on the elevator in one trip? So each cement bag weighs 95. We have the operator that goes up and down with the weight, with the cement bags. And the question is how many we can put in the elevator in one trip. Ready? Good. So can anyone tell us what to write here that has to be less than or equal to 2,800? Yes, that's it. Let's solve the inequality. It's a linear inequality. Excellent job. Thank you. It's a linear inequality. How do we solve it? What do we have to do first? Of course, we have to subtract 245. So we have 95x is less than or equal to 2,800 minus 245. I have a 5. I have another 5. And 2 from 7, I think I have a 5. So correct me if I'm wrong. I think I'm okay, but maybe not. Thank you. Finally, we have to solve for x. How do we solve for x? Yes. So now this will take me a little bit longer to divide, so I'm going to use the calculator. 2,555 divided by 95, I got 26. Less than or equal to 26. Now, in this particular case, the problem should have a solution like this. No, of course not. We are talking about number of bags. It's either between 0 and 26. So I would not even write it like this, because this includes 1.3. We don't have a bag that is 1.3, right? We don't have a bag plus 0.3 of it. So I would not use this notation. I will not use this notation. Here's the notation that I would use, which you will probably see in my lab math. So x having the property that x is 0, 1, 2, ... 26. So this is the solution set made out of number of bags, eggs, x, number of cement bags, having the property, this bar represents having the property. Or what do we know about x? We know it has the property that it can be 0, 1, 2, and not more than 26. Very good. Okay, I would like to look at how to earn an A in a course like 130. Any questions on this problem?
That's how we're doing that, right?
For this particular example, yes. Can I have 2.5 bags in the elevator? No. So it has to be an integer between 0 and 26. Okay, so let's look at problem 130 on page 205. To earn an A in a course, you must have a final average of at least, so final score average, they say, of at least 90%. Of at least 90%. Even if we don't read on, what will you write immediately? That's it, of course. Excellent. At least. On the first 4 examinations, you have grades. So test 1, 2, 3, and 4. Test 1, the grade was, they say, 86. On test 2, they say the grade is 88. On test 3, they say it's 92. And on test 4, 84. So these are the first 4 test grades. If the final examination counts as 2 grades, so final is X, and it counts twice, so final X. What must you get on the final to earn an A in the course? First, we have to talk about average. So how many numbers we have here? 6 numbers. The average of 6 numbers is the sum of all 6 divided by the average of 6 numbers divided by 6. So the average of 2 numbers will be, we add up those 2 numbers and we divide by
2.
The average of 10 numbers, we add up 10 numbers and we divide by 10. Perfect. Okay, so let's do that. And the average, they say, has to be greater than or equal to 90%. Okay, I'm ready. So please dictate.
So do we need to write the average first?
I have to write inequality. This is the inequality. Can you please tell me how to write the average of these numbers? Please dictate. Just dictate what you would write the average for these 6 numbers. Don't worry about anything. It doesn't, we have to tell me so everyone sees what we're doing.
You put 86 plus 88.
That's all I want you to say.
Can you just add it all together, make it faster though?
No, because I want everyone to see what we're doing first.
Okay.
Of course we have to add them up,
Right.
but I wanted the first step for everyone to see what we have. So we add up 4 numbers that we already have, and we add x plus x, and an apple plus an apple is 2 apples, so we have 2x, correct? Good. So now what did you get when you added up those 2? The 86 to 88 to 92 and to 84? I got 350,
Yes.
correct? Okay, correct me if I'm wrong anytime. So this is 350 indeed, plus 2x divided by 6 greater equal to 90. Excellent. What will you do next? Say it again. I couldn't hear you.
Subtract the 50 on both sides.
Get rid of the fraction.
We have to get rid of the denominator. We cannot remove any term from the top of a fraction before we eliminate the denominator. That's our first step. Is that clear, everyone? Okay, so then 350 plus 2x greater than or equal to 540. Would you agree with that? Yes, everyone?
Yes.
Good. Now we are going to subtract 350 from both sides. When we subtract 350 from both sides, we get, is it 190 on that side? Okay, so 2x going to equal to 190. Final step. X must be greater than or equal to So in order to keep an A average for this course, we have to make sure that the final exam grade is at least 95. And then it's guaranteed to get an A. We're guaranteed to get an A in the class. Perfect. Any questions? Okay, so chapter 1 is finished. Okay, so at least by tonight, everything, including 1.6, 1.7, you have time till Wednesday because I just finished it. So it will not be fair for you to have to complete 1.7 tonight. So Wednesday, yes.
So but 1 + 1 through 6 done tonight.
Tonight, please, 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 so you don't fall behind. And then you can go back. If it's not complete 100%, it's fine. You can go back, but it's going to be difficult to go back later. So that's why I'm trying to everyone to stay together. Okay, chapter 2. Chapter 2 deals with functions. It's a lot of work. We're going to try to stay only between 2.1 and 2.4 before we have test 1. So test 1 will include everything in chapter 1 and only four sections from chapter 2. If we have time to do 2.5, we'll do 2.5 too, but I always end up splitting that 2.5 into 2 different pieces, and I would rather not. Okay, so we know a lot about functions, and most of what I'm presenting probably in the next few minutes you're gonna remember. So let's look at 3 scenarios. This is 1, 2, and here's the third one here. So let's suppose I have x equals 1, and then 5, and then -3. And I'm going to create some connections. I'm going to say that y equals 0, y equals -4, and y equals 10. As you notice, to each x value from the first set, it corresponds to each one here. It corresponds only one y value. Agreed? 1 corresponds only to 0, 5 only to -4, and -3 only to 10. Agreed? Okay, so this is what it's called a function. This set is a set of values of x or domain. This set is values of y or range. I'm going to create the next connection, the next link, but I'm not going to put numbers. You understand what I'm doing. So let's say I'm going to do this. And these are all 3 different numbers, and these 2 are different numbers. And I'm going to ask you, is this a function? Don't answer it. Just let me just point out something. To each x value, only one y value. To each x value, only one y value. To each x value, only one y value. Is this a function?
Yes.
It is a function. It doesn't have a property, very special property that this one has, but it's still a function. This is still its domain, and this is still its range. Here's a third scenario. So this number corresponds to these 2, and this number corresponds to this one. Is this a function? No, this is called a relation. This is still its domain, and this is still its range, but it's not a function. It's a relation. Is it possible? Yes, it's possible in real life situations. But it's not a function. Also, we can be given graphs to identify whether it's a function or not. Any questions so far? We pretty much remember this part, correct? Okay, so now let's look at some graphs and decide whether they represent functions or not. So I'm just going to pick something here. Here's the second one. And one more. So let's look at these 4 graphs and identify whether these graphs represent functions or not. Remember what we're looking for. For each x value, how many y values? Exactly 1. And this is called the, what am I going to use now? Vertical line test. By the vertical line test, when x is -3, I read how many y values? When x is -3, how many y values do I read? 2. Is this representative of a function or a relation? Of course. Next one. Please cut it or imagine you cut it with vertical line tests. And for each vertical line test, for each vertical line I meant to say, how many different y values do I read? Is this a function or a relation? The next one, by the vertical line test, what do you conclude? Is this a function or not? For this x value, let's say x equals -1, I read 2 y values. Is this a function or a relation? What about the last one? Can anyone remind us what it is, what it represents? What is this? What is the graph of this function? What function it represents? Anyone remembers? The graph of this, what function is this? Right, but it's linear. That's all I'm asking. We don't have the exact equation, but it's one form, y equals mx plus b. But all I want you to say is that we know it's a linear function. Good. Is the linear function a function or a relation? Of course, it's a function by the vertical line test. Each vertical line will cross the graph in only one point, so it is a function. Okay, now I would like us to look at a graph and analyze it, and analyze it, and analyze it. Here's a graph. Many questions here. I'm sorry, it's 82 on page 231. 82 on page 231. I have lots of questions for you here. Ready? Is this a function? By the vertical line test, this is a function. Perfect. Is this function defined or has a domain between I would adjust something else, but I'm going to have to go back and say, what is the domain of this function? Say again. So look at the graph. What is the first point you see from left to right? Right, I see -6, whatever, right? So that's where the graph starts. There is nothing to the left-hand side of -6, correct? And this point doesn't really exist. It does not. It's an open point. So I'll say that the function starts at -6, but not exactly at -6, in the immediate vicinity of -6 to the right. And where does it, so I can cross it with vertical lines, I can cross it, I can cross it, I can cross it till what point for x? Right, beyond 0, I don't see anything. If I want to cut the graph here with x equals 3, I can't, because the graph is not there, right? So then what is the domain of this function one more time? -6 to 0. So I'm writing it here because I don't want to go switch. So this is -6, 0. This is the domain. -6 does not exist, so it's an open point. 0 exists. It's a full point at 0 for x. So that's the domain. Can anyone give us the range? Now we're cutting the function with horizontal lines. What is the lowest horizontal line that will touch the function? -3. Where is the highest horizontal line that will touch or cross the function? Right, but without 4. Right? It's an open point. This horizontal line will not hit the graph. Will go through the open point, not hit the graph. So then the range of this function would be between, indeed, -3, comma 4. But with a parenthesis, not with a bracket. Okay, does this function have an x-intercept? Can anyone give us the x-intercept in the ordered pair format? I have the dry erase. You have to use that one. Okay, so the ordered pair format for the x-intercept is, comma, very good. Does it have a y-intercept? So this is the x-intercept. And this is the range. And this is the domain. I don't longer like turning my back on you anymore. It's been 12 years I haven't written on a board. Okay, so y-intercept, please.
0, -3.
Indeed, 0, -3. This is an ordered pair format. 0, -3. Can you tell me whether this function, as x increases from -6 to 0, does the function decrease or increases? Of course, it's silly, right? It decreases. So we write that f decreases on -6, 0, parentheses. We're going to talk about this again. I would like you to give me f of -2. What am I given here? I'm given the x. How much is x? -2. When x is -2, or when I'm told that x equals -2, then I know I have to cut the graph, or imagine that I cut the graph with a line that is x equals -2. It crosses the function somewhere, and then I approximate the y value of the point. What will you approximate it with or by? Point 0.2. What is the ordered pair that you read from? X comma y. Final question here. Find x such that f of x equals 2. Find x such that f of x is 2. What does this mean? Here I was told x is -2. But what am I given now? I'm given y, which is 2. So I draw a horizontal line at 2. I see it crosses the graph at this point, and I will be reading the x value. Please approximate whatever, I'll accept it. F of is 2. -5.2. Which ordered pair did you just read from?
5.2.
Yes, always x is first, y is second. Questions on this? Okay, I'd like us to look at another, 231. I would like us to look at this graph now. Ready? So can anyone give us the domain of this function? -infinity till I cannot cut it with a graph, with a line, with a vertical line, from -infinity till, and then union from 1 to infinity. Okay. What about the range? To 0, union No, I cannot. I will be missing infinitely many numbers between 0 and 1. So it's from negative infinity to 0, union from 0 to infinity. Is that clear? Yes? Please say no if it's not clear. It's not clear? Which part? Which one? So I can move from here because to show you over there better. I mean, I can do this. Maybe it will stay. Maybe. Okay. So can I cut the graph here with a vertical line? Yes? Can I cut it here? Can I cut it here? Yes. Can I cut it here? Because the point exists, right? Can I cut it here? Can I cut it at 1? No, I cannot cut it at 1. Can I cut it after 1? Yes. Can I cut it at 2? At 4? So what is the domain? Everything except, that's it. So that's what we have to write. So the domain is negative infinity to 1, union 1 to infinity. Exactly how we wrote it before. The same thing with the range, right? Can I cut it horizontally? Yes? 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 Tell me when I can't. Right, but then after 0, can I? Good. That's exactly it. So between negative infinity and 0, union 0 to infinity. This is the domain, and this is the range. Clear? Yes? Okay, so now I would like us to look at some points. For example, can you tell me how much is there an x-intercept?
Eventually. No.
It's a very good point. We're going to talk about the asymptotes in chapter 3. Very good point. Eventually, maybe. Okay, but no. The answer is no. Okay, what about the y-intercept? Yes, where? 0, negative 1. Can you tell me whether this function is increasing or decreasing? Is it increasing or decreasing? I knew it was going to happen, but I didn't know when. Okay, so the function is always decreasing. Perfect. I know I have 10 minutes left, so